So our subject today is IoT and energy. Can everyone see it?
Yes.
Great. So subject, how is IoT enabling the renewable energy transformation? And IoT will play an extremely central part in it. And we're gonna have six panelists today discussing the subject from different industries. Let me shortly tell you a little bit about the background. I mean, what we will be talking about today is the integration of renewable energy, improving energy efficiency, predictive maintenance, smart grids, monitor and control, energy security, and insights from IoT. And basically, what this will lead to, the discussion today, is hopefully give all the attendees a clearer of the idea what we're talking about. So what's the problem? The problem is basically we have renewable energy coming in, and we have instead of a supply network where we have distributed energy, and we need to integrate this energy. And where's the problem? It's on all levels of the energy system. It's on levels of the utilities, the energy producers, and the consumers. Traditionally, the utilities were the main energy producers. This is going to change, or is already changing on large scale. Nowadays, the utilities, at least here in California, for example, are managing the grid. But we will hear more about this from our audience today. Why do we need that? We need it because we need a reliable energy supply, and we could solve part of it through a smart IoT and enabled energy ecosystem. And here are our panelists: Arie Brish, who is currently professor at St. Edward's University and is partner at Levant Energy Group. He has worked in renewable energy and other roles. We're involved in solar companies and so on. Where do you see IoT sensoric happening in those generation and renewable energy generation parts?
Good evening. Thanks for having me and the panel organized. You break the word IoT to two things, so two elements. One is the things we're talking about. These are all the physical elements out in the field. And one is the so-called internet, but I prefer more to look at the I as integration, not just internet. I mean, the connection of all the things, all the devices into some central office is pretty trivial. The problem or the challenge, the real challenge, is what do you do with all this data? And the problem or the challenge becomes even more important when you talk about renewable energy. When you have a generator, predictable gas generator, or nuclear generator, a coal generator, the in and out is pretty predictable. when you start to deal with solar and wind, and here in Texas, wind is very significant proportion of the energy input. All the inputs becoming unpredictable. The wind is changing. Yes, you can predict that tomorrow will be southwest wind of 10 miles per hour, but all the gusts are changing direction and changing speeds. So the importance of these sensors in the field to provide the input is becoming very critical to be able to respond correctly to the changing conditions, whether it's a wind changing direction, changing speed, clouds, putting shadows on the solar panel, everything, all of this. And all of that is coming into a data center that crunch all these conditions and optimize how to allocate the different energy sources and integrate all the energy sources. So this is on the supply side. On the demand side, you have things, again, in your house. Those are the thermostats of your air conditioner, for example. And those are a little bit unpredictable as well, because the forecast could have been 95 degrees, but it happened to be 97. That's a major change of load on the grid. So you have millions of unpredictable inputs that you need to react in real time. And that's where the challenge and the need of IoT comes. In predictable generation, we had devices, sensors monitoring what's going on in the generator and the oil rig 30, 40, 50 years ago, but those were pretty much predictable, and their role was more in the maintenance and to detect if there is a malfunction somewhere. But now with the renewable energy, it's almost a real-time thing, not almost, a real-time thing that you need to adjust every second to optimize.
That brings me to Arie. What do you think needs to be done in security for IoT and energy? And in the infrastructure, I mean, we see that a lot of the fires here in California are caused by the grid, basically. And that's not, I mean, you could remedy it with IoT to a degree where you would be much faster recognizing what's happening on the physical ground, but actually it has to do with probably too many power lines not being equipped for the load that goes through, or power lines too near to the tree lines and so on. I just read recently that the CEO of PG&E suggested to put all power lines underground now, which would be probably very expensive, but considering the costs and lives it costs, it did cost. So Arie, could you speak to that security, cyber security, and of IoT and security aspects as such?
Okay, there are several dimensions to the security and cyber security of IoT. The major source of the risk here is the fact that all these assets are sitting somewhere out in the field, maybe with a little fence around it, but not much more than that. There is no security guard or anything like that. So you can walk in, cut the fence, connect some device into the IoT device and inject some bad stuff into the grid. And from there, you can go in two directions. One direction is the risk to the grid itself. You can shut down the entire electricity to a whole big city or a whole state or a whole country. You can open the floodgates of a major dam and drown a whole city downstream. So all these damages can be done virtually if you just connect the right device to an IoT elements somewhere in the middle of nowhere that nobody even watches. So there is a whole field of cybersecurity that address that risk. The good news is cybersecurity for OT, operational technology, that's what they call this network, is a little easier than cybersecurity for pure computer at home or the office, because the traffic on the grid, on the control of the grid is more predictable. They send a packet of status report every so many minutes, you know, on the dot. So if there is any deviation from that, that's a red flag for the security system. The other risk, if companies are not careful, the operational network can leak into the IT infrastructure of a company. And we saw that in 2013, when Target were hacked and thousands of credit cards were stolen, the entry point for the hackers was the network between the HVACs in the system. So somebody did not pay attention and created the leakage path between the control of the HVACs on the roof of the Target stores and into the credit card databases. So that's a big no-no, you know, allow something like this to happen. There is another example, maybe not from the energy, but a few years ago, the government did an experiment and penetrated the aircraft control, commercial aircraft controls or flying system by connecting a device to the entertainment system of the airplane. So one way to, like in physical security, you create compartments that is difficult to pass from one another. The same thing needs to happen in the cyber, in the internet, in the network.
Thank you.
So,
what are the less environmental impact options available besides the traditional ones? I don't really understand what particularly is meant here. Maybe someone could answer that. Okay. Yes, Arie.
I'm not sure if that's what the question was intended to, but there is no such thing as creating or generating energy with no environmental impact. The trick is to create the right mix so you don't kill a whole ecosystem environmentally. And like any technology you can think about create some environmental impact, whether it's wind turbines, visually killing birds, solar panels on a large scale, putting shadows on the desert, and you know, interfering with the ecosystem of different snakes and lizards and what have you. If it's a hydro planet, think about all the lake it creates. It covers with water a whole ecosystem on one side. Think about all the pollution impact of creating or manufacturing all the concrete you need to build this large dam. So any clean energy has some environmental impact. If you do too much of any one thing, you create, the impact is too destructive. If you find the balance between the different technologies, the impact will not be that destructive. I'm not sure if I answered the question.
Yeah, I think that's a good idea. I mean, I think low impact, and while you were talking, some things came to my mind that and that's been done for thousands of years in Mediterranean countries to paint your houses white. Yeah, that's has a very low impact, very low environmental impact, because you have to paint them anyway. But it makes a big difference for if your roofs are white, and it's a very low, let's see, very low hanging fruit. Or in some cities I saw in India paving the streets white also. Very low impact with a lot of result.
Living in the Middle East for many years, we used to have a flat roof in one of our houses. You paint it white in the summer, you paint it black in the winter. You also build the houses with very high ceilings, so in the summer the hot air goes up, the layer of hot air close to the ceiling, but down where the people are, it's much cooler.
Yeah. Thank you. Another very interesting, it's not IoT, but it's a question that came up. So signed up for the event. I think we had about 100 today here live. And also want to thank very much the North Texas IoT group for co-hosting this and for being with us. It's always great to work with you, and wishing you a wonderful upcoming weekend, Labor Day weekend, and I hope to stay in contact. And thank you so much for all the speakers and their input.